force equal to mass into acceleration, which can be written as mass into V minus U by T. Now what is T? T as usual is always time. Got it? Now let me start with very simple questions as always. Let's say a body of mass 2 kilograms starts from rest and attain a velocity of 5 meters per second. Find force acting on the body. Find force acting on the body. The question is here, a very simple one. I've said what would one. So all of you can take down the question.
There's a lot of background noise. But I got 5 newtons.
You got 5 newtons. Okay. Let others also come up with the answer. 5 newtons. Others. Okay. Arjun, what is your answer? Akshat, what is your answer? Keetana got 5 newtons. Okay. Alex, what is your answer? Yuvraj, what is your answer? Yuvraj, 5 newtons. So all of you got 5 newtons. Varnika, I'm yet to get an answer from you. Varnika, Alex. Okay. It's a simple one. I want everyone to come up with the answer. Akshat, what about you? Yeah, Veda can. Is it better now? Okay, so it's a very simple question. So what is it? Now, all things directly everything is given. Mass is 2 kilograms. What is initial velocity is 0. Final velocity is 5 meters per second, and time is 2 seconds. So F equal to m into v minus u by t, right? So that is equal to how much? 2 into 5 minus 0 by 2. So that becomes 5. Very simple one, and I think all of you got it right. So let's slightly increase the level of the question. Try to is I take another situation. A force of T Newton acting on a body changes its velocity from 40 meter per second to 30 meter per second in 2 seconds. So changes its velocity from 40 meter per second to 30 meter per second in how many seconds? In 2 seconds. Fine. That's fine. So 40 meter per second to 30 meter per second in 2 seconds. The question is, find the time required for the body to stop if force continues to act on it. Is the question clear to you? Is it visible? I repeat, a force of 50 newtons acting on a body changes its velocity from 40 meter per second to 30 meter per second in 2 seconds. Find the time required for the body to stop if the force continues to act on it.
Sir, are you asking for how much time it will take for the object to stop, including the 2 seconds or excluding it?
Well, I'll take it, including the 2 seconds as well as, I understood the answers, right? Excluding the 2 seconds, what will be the answer? X. All of you got it? So how do we get it?
Find the acceleration. So, so we know that the initial acceleration is 40 and the present, initial velocity is 40 and the present velocity is 30. So so it will be 30 minus 40 upon 2 because 2 is time, and we get negative 5 then, that is deceleration. So we know per second there is a deceleration of 5, so we just calculate it. And
okay. So how will we do this? Again, not a very difficult one. So here what I can do is I'll find the acceleration. What is the acceleration here? Can I say acceleration is always final velocity minus initial velocity by time. So how much is that? 30 minus 40 by 2. That is minus 5. Now when it stops, what is final velocity? 0. If I take from 30 meter per second, what is initial velocity? 30 meter. What do I know? V equal to U plus H. So 0 equal to U is how much? 30 plus minus 5 into T. So this will give me T equal to 30 by 5. That is 6. Right? That was also, all of you have done it. So now shall we increase the level of the question? Shall we increase the level of the question? Confident, yes. Alex, shall we increase the level? Okay. So now let's see who can do this. So the basics are clear to all of you, right? So a force of, I'll say a force of 40 Newton acts on a body of 4 kilogram. A force of 40 Newton acts on a body of 4 kilogram at rest. After 2 seconds, a force of 20 Newton starts acting in opposite direction. After another 2 seconds, 20 Newton more acts in opposite direction. Find the final velocity, or I'll say find the velocity of body So I'll say here, first part A after 4 seconds, B after 6 seconds, C after 8 seconds. I hope it is clear. So, if I want to draw it pictorially, first only 40 Newton is acting. Now, after some time, what is happening? This 40 Newton and this 20 Newton. After some time, what is happening? This 40 Newton, this 20 Newton, and this 20 Newton. Just go through the question and let's just check whether it is clear or not. Any doubt in the question? You understood? A 40 Newton force starts acting and continues to act on the body. After 2 seconds, what is happening? 20
Yes,
Newton.
sir.
20 Newton force acts in opposite direction. After another 2 seconds, another 20 Newton acts in opposite direction. You are required to find velocity of the body at 4 seconds, 6 seconds, and 8 seconds.
Yes, sir.
Very good. So let's see who would get the answer for this.
Excuse me, sir. I have a doubt.
Yes, sir.
Yeah. So who has a doubt?
Sir, I have a doubt.
I have a question too.
Okay. Go ahead.
Sir, the 4 seconds, 6 seconds, and 8 seconds include the 4 seconds in the question or excluding the 4 seconds in the
It
question?
is including the 4 seconds in the question. So your time starts from the force of 40 Newton starts acting on it.
Yes, sir. Thank you, sir.
Okay. Yeah. Naisha, you had some question?
Yeah, so it says after 2 seconds, the force of 20 N starts acting in the opposite direction. After another 2 seconds, 20 Newtons more starts acting in the opposite direction. So like the opposite of the initial direction or opposite of the after 2 seconds direction?
Opposite of the initial. This is the initial condition at t equal to
Okay.
0. This is equal to 2 seconds. That is equal to 4
Oh, okay. I didn't see
So,
the
sir,
picture.
every 2 seconds, 20 newtons is added to each side and not just one.
No, it is only for two intervals of 2 seconds. After that, there is no more 20 Newton added.
Okay.
Okay, yeah. So that becomes a slightly, you need a little more mathematics to answer that. Yuvraj is ready with the answer. His answer is 0. Okay. Let everyone give the answer. You have full 3 minutes to solve this question.
Yes, sir.
Yes, sir. Arya. I'll just have a little water and come. Fine. Yeah. Just keep doing.
Yes, sir.